When dealing with transformer primary and secondary protection, understanding the rules for conductor sizing is crucial. Article 450.3b of the National Electrical Code, or NEC, permits sizing the primary overcurrent protective device, or OCT, at up to 250% of the transformer's primary current under specific conditions. However, this allowance does not extend to the sizing of the primary conductors themselves. The code distinguishes between the overcurrent protection for the transformer and the ampacity of the conductors feeding it. When sizing the primary conductors for a transformer with primary and secondary protection, you must base your calculations on the transformer's nameplate primary amperage, not the increased amperage value derived from the 250% overcurrent protection allowance. This means you need to locate the transformer's nameplate and identify the primary voltage in kilovolt ampere, or kVAR rating. The formula to determine the primary current is as follows. You divide the kVA by the primary voltage and then multiply by 1000 to convert kVA to volt amps. For example, if you have a 50 kVA transformer with a primary voltage of 480 volts, the calculation would be 50 kVA divided by 480 volts, then multiplied by 1000, resulting in approximately 104.17 amps. This 104.17 amps is the value you would use to determine the minimum ampacity of your primary conductors before applying any adjustment or correction factors. Once you've determined the required conductor ampacity based on the nameplate current, you must select a conductor size that meets or exceeds this value. You'll need to consult NEC Table 310.16, which provides ampacity ratings for various conductor sizes and insulation types at different temperature ratings. Factors such as the ambient temperature and the number of current-carrying conductors in a raceway or cable assembly can affect the conductor's ampacity. These factors require adjustments or corrections to the ampacity values listed in Table 310.16. For example, if you have more than 3 current-carrying conductors in a raceway, you'll need to apply a directing factor as specified in NEC Table 310.15 cone. Similarly, if the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, you'll need to apply a correction factor based on the conductor's temperature rating and the ambient temperature. These adjustment and correction factors ensure that the conductor's operating temperature remains within its insulation rating, preventing premature failure and potential fire hazards. After applying all necessary adjustment and correction factors, the final adjusted ampacity of the conductor must still be equal to or greater than the transformer's nameplate primary current. Now let's discuss the overcurrent protection. While the conductors are sized based on the nameplate current, the primary overcurrent protective device can be sized up to 250% of the nameplate current, as permitted by NEC Section 450.3b, under specific circumstances such as having secondary protection. This allowance is intended to accommodate inrush current, which is a temporary surge of current that occurs when the transformer is initially energized. The inrush current can be significantly higher than the normal operating current, and a standard overcurrent device sized at only 125% of the nameplate current, as required in some other situations, might trip unnecessarily due to this inrush. The 250% allowance provides a buffer to prevent nuisance tripping while still protecting the transformer against sustained overloads and short circuits. It's essential to understand that the 250% rule is a maximum limit, not a requirement. You can always choose to use a smaller overcurrent device if you believe it's appropriate for the application and can still accommodate the inrush current without tripping. In selecting the appropriate overcurrent device, you must also consider its interrupting rating. The interrupting rating is the maximum fault current the device can safely interrupt without failing. The available fault current at the transformer's primary terminals must be less than the interrupting rating of the overcurrent device. This ensures that the overcurrent device can effectively clear a fault without causing damage to equipment or creating a safety hazard. When coordinating primary and secondary protection, you must ensure that the overcurrent devices are selectively coordinated. Selective coordination means that only the overcurrent device closest to the fault should trip, while upstream devices remain closed. This minimizes the extent of the power outage and allows the rest of the system to continue operating normally. Achieving selective coordination typically involves selecting overcurrent devices with different time current characteristics so that the downstream device trips faster than the upstream device for the same level of fault current. Consider a practical example: a 75 kVA transformer with a 480 volt primary and a 208 volt secondary. First, calculate the primary current. 75 kVA divided by 480 volts, then multiplied by 1000 equals approximately 156.25 amps. This is the minimum ampacity required for the primary conductors. Next, select a conductor size from NEC table 310.16 that has an ampacity of at least 156.25 amps, taking into account any applicable adjustment or correction factors. For instance, a number 1/0 AWD copper conductor with THHN insulation, which has an ampacity of 170 amps at 75 degrees Celsius, would be suitable if no dating is required. Now, determine the maximum allowable size of the primary overcurrent device. 156.25 amps multiplied by 250% equals 390.625 amps. Therefore, the primary overcurrent device should not exceed 390 amps. A standard 350 amp fuse or circuit breaker would be appropriate in this case. Finally, verify that the interrupting rating of the overcurrent device is sufficient for the available fault current at the transformer's primary terminals. Also, coordinate the primary and secondary overcurrent devices to ensure selective coordination. In summary, when sizing conductors for a transformer with primary and secondary protection, always use the transformer's nameplate amperage as the basis for your calculations. The 250% overcurrent protection allowance applies only to the overcurrent protective device itself and not to the conductors. Always consider adjustment and correction factors for conductor ampacity. Select an overcurrent device with an adequate interrupting rating and ensure selective coordination between primary and secondary protection. Remember to consult the latest edition of the National Electrical Code and any applicable local codes for specific requirements and guidance.